about these navigation story problems and promised you guys some time in class to work on those today. We'll do that, but I was going to start with questions if anybody had any burning questions they just had to get done. Katie.
How do you know when to add or subtract the questions with the
Okay, so that would really depend on the picture that you draw. So for example, if we have theta equals cosine inverse of, 0.87, and then say theta's between 0 and pi, we'll just keep it simple here. So this has to be quadrants 1 or 2, right? This has to be quadrants 1 or 4. So I know that this has to be then in quadrant 1, right? So here's 0. There's my terminal. Well, let's use a color. Here's terminal and initial. So that's my theta. In this case, my phi is the same spot as my theta, right? So what I'm going to relate is the theta, the phi, and that value from the x-axis that makes up the other arm of my phi together. So I'm going to compare theta and 0. So theta is bigger than 0. Agreed, because it's past 0. So I know that I should be adding something to 0. And how much past 0 did we go? Phi, past 0. So it just depends on the picture, right? So if all the angles are positive and I go past the x-axis, I'm adding. If all the angles are positive, or if all the angles are positive and I haven't got to the x-axis again, I'm subtracting, basically, right? So if we had something over here where this is my phi, then I'd be subtracting. Does that feel okay?
Yeah.
And then it's the opposite if the angles are negative. Because again, going past it makes it more negative. So it's smaller, getting smaller. Does that feel okay?
Yeah.
Okay. Allie.
Can you review how to do one of the examples from worksheet 4, 5, and 8?
Sure. 5 through 8, you say?
Yeah.
Sure, let me grab that. Does anybody have a preference on 5 through 8? Allie doesn't seem to be very committal about anything in particular, which is fine. You don't have to be. I'm just trying to 2 birds, 1 stone it, which is a weird saying. Nobody wants to be my second bird? Yes! Way to go, bird number 2. Oops. All right. So on these, we want to start from the inside. So we have theta equals cosecant inverse of that. Right? Remember, arc sine is the same, or arc cosecant is the same as cosecant inverse. So that's the same thing as saying cosecant theta should equal 2x plus 1. Now remember my right triangle definitions for cosecant is hypotenuse over opposite So if I draw my right triangle and I label one of the angles theta, the hypotenuse should be 2x plus 1. The side opposite should be 1. And then I need to find this side, which I'll call y for the sake of argument. So using the Pythagorean theorem, 1 squared plus y squared should equal 2x plus 1 squared. 1 squared is 1. 2x plus 1 squared is 4x squared plus 4x plus 1 when I FOIL that thing out. I just FOILed it in my head. Is that okay?
Yeah.
Okay. So I can subtract 1 from both sides. And then we'll square root both sides. Since this is a side length of a triangle, I'm going to drop the plus or minus. And depending on how fancy you're feeling, you could simplify this a little bit. So you should notice that you could factor off a 4. And the square root of 4 is just 2. So I'm going to just replace that with 2 square root x squared plus x. Is that okay?
Yeah.
And then my final step then, I can do cotangent on this theta. So I know that cotangent theta is equal to adjacent over opposite. So that's going to be 2 square root x squared plus x over 1, or just 2 square root x squared plus x. And that would be my final answer. So I use the inside stuff to build my right triangle, and then I execute the outside part on the right triangle I built, is the general process. Tessa, does that feel okay to you? What's the most common mistake there, assuming you remembered how to do it? It's forgetting to FOIL on that step. Many of us would probably just try to distribute the exponent and say that's 4x squared plus 1. Or even worse, 2x squared plus 1, and only distribute the exponent onto the x and not onto the 2 also. But that would be the expected mistake I would see if you got it wrong, would be just, yeah, algebra 1 mistake. It happens. I say this because that's the expected mistake I would do, you know.
Yeah.
It's like, it's not, don't feel bad if you're like, I did that. Yep, that was me, I did that. It's like, well, that's normal. Try not to do it again. I'll keep giving you a hard time about it, but it's one of those habits you just got to break, you know. Anybody else? Alrighty then. Well, I'm going to stop talking, let you guys work on your navigation problems. If you have questions on anything, or if you just want me to check your work, or you're stuck or whatever, feel free to come up and bother me. I'm just going to kind of stay out of your way though. Cool? Everybody happy? Plenty of time to get some stuff done. Yay! What's going to happen next class? Review day. Class after that? Test. Which is Monday then, right? For you guys? Okay.